Hey kiddos, in this lesson we're going to go over graphs of proportional relationships. Specifically, our objective is that by the end of this lesson, you should be able to represent proportional relationships using graphs and equations. You should be able to look at a graph, tell whether or not that graph is proportional. You should be able to look at a table and tell whether or not that table, the x and y points on that table, the input-output, whether or not they are proportional as well. What are going to be the criteria for success? Well, there are three. One, you can determine whether or not the quantities are proportional using the graph. You can find the unit rate of a proportional relationship, again, using the graph. And then last but not least, you can create an equation to represent the proportional relationships. Let's take a look at example number one. Well, before we get to example number one, as always, what are the key vocabulary words? In this particular lesson, constant of proportionality is going to be a term that you're going to hear me say a lot. The constant of proportionality is just exactly what it sounds like. Constant. What is a constant? Well, a constant is a number that doesn't change, that it's the same. And proportionality means what? That when we're looking at two ratios, do those two ratios, are they equivalent to each other? And so when we talk about the constant of proportionality, it's going to be the value or the number that represents the multiplicative relationship between the quantities x and y. Multiplicative relationship meaning, hey, are we able to multiply this constant of proportionality for either the x or the y, or are we dividing by this same number, and it's going to be the same value that keeps occurring over and over again for that particular set of ratios. Great. Now let's take a look at example number one. Example number one, we have our x and y coordinates, and we're going to graph these coordinates and then look at the graph and say, hey, does this create a proportion? Do the x and y's, are they proportional? So when we graph these points, first have our graph, we have our x coordinates, we have our y coordinates. Remember that these are not 2 points. This actually should be, let's go ahead and write that number in. I don't know why you're able to see it. This should be -2, and then this should be 0. Okay, so now looking at this, if we graph our first point, 1, -2, it's right there. Our next point is 2, 0, so we go over 2. And because it's 0, we're not going up and down, so it's just going to be right there on the x-axis. +3, +2. We first do our x, +3, and then we come up. So our point should be there at +3, +2, and then last but not least, +4, +4. So there are a couple things that we'll be able to see whether or not a graph is proportional. Number one, when you plot your points, do those points create a straight line? If those points create a straight line, then that's one criteria for a proportional relationship, because it's all going straight. And what do we see? Yes, that is the case. And then number two, we want to see whether or not that line, those points, do they go through the origin? If they go through the origin, then yes, then you have a proportional relationship between your x and y values. However, when we look at letter A, does that go through the origin? The answer is no, it doesn't. So in the chat, go ahead and type the word origin, because here, this particular set of points does not go through the origin. And because it doesn't go through the origin, we can say that this line is not proportional. All right, let's take a look at our second point, letter B. When we take a look at letter B, once again, we have all our points here. When we take a look at letter B and we start to plot them, our first point we see is 0, 0. Because this is 0, 0, that's the first criteria that we need in order to state whether or not this is proportional. But that's not the only one. We've got to plot all these points and see whether or not it creates a straight line. All right. What about 2, 2? 2, 2 is there, 4, 4 is there, and then 6, 6 is there. When we look at these 4 points, yeah, they draw a straight line and they go through the origin. Because of those two criteria, we can say that this graph, this second point here, this second table here, is proportional because it has those two criteria of straight line and it passing through the origin. All right. Now, let's take a look at our next example. With this next example, we're now going to be able to determine, like we were mentioning before, constant of proportionality. is there a constant proportionality present for this table or this graph? First thing that we want to do, take a look at our points. We see that the graph is a line. It passes through the origin. So the time and the distance, or our x, which is our time, and our y, which is the distance in miles, are proportional. To find the speed in miles per minute, we're going to use a point on the graph to find what the unit rate is. In order to find the unit rate, we just take one of those points. In this case, we're going to say 2,1. The point 2,1 indicates that the subway car travels 1 mile, that's a distance, for every 2 minutes. That's our time. So the unit rate would be, if we're dividing the distance, which is miles, by the number of minutes, which is 2. So it'd be, hey, 1 to 2, or 1 over 2, or 1/2, which means that for every half mile that is traveled, the amount of time that has passed is going to be 1 minute. So for every minute, half a mile is traveled with this subway car. Okay? So what is our constant of proportionality in this particular example? Well, constant proportionality, as we said, is that same number that's being repeated over and over and over again. And in this case, it's that number that is 1/2. That our unit rate, which is 1/2. So the constant of proportionality is let us know that, hey, for every 1 minute, half a mile is being traveled. So how can we now take what we've just talked about in terms of whether or not a table, or whether or not a graph is proportional? Does it go through the origin? Is it a straight line? When we take a look at question number 3, we see both of those things. And then secondly, how are we able to calculate what the constant of proportionality is? We can determine what the constant of proportionality is by, once again, finding a point on the graph and then dividing to figure out what is going to be the value that's repeating over and over again. And in this case, we see that the graph shows that the area, which is on our y-axis in square feet, that a robotic vacuum cleans in X amount of minutes, and we want to find what's the area that's cleaned over 10 minutes. Well, to figure that out, first, we see those two things. Line that passes through the origin. We can also write an equation to represent the relationship between the area and the time. The relationship between area being y and the time, which is x. What is that equation going to look like? Well, like we just saw in the last question, where we saw, hey, for every 1 minute, for every half a minute, for every minute that was in our last question, we saw that for every minute that passed, half a mile was traveled. We can do the same here for this particular question, because for every minute that passes, we can see that 16 square feet are being covered. So if we go to 116, which is this point here, whatever the x coordinate is that's equal to 1, whatever is the y coordinate, or the y coordinate, that's going to be our constant of proportionality. And the equation for that is going to look like this. Y, which is our outcome, which is the number of the square feet in area, is going to be equal to the constant of proportionality, which is represented by k, times x. And we see here that that is equal to 16. That y equals kx, where y is our area, k is the constant of proportionality, x is the number of minutes. And we see in this particular example that, hey, for every 10 or for every minute, 16 square feet is being vacuumed. So that means if we're vacuuming for 10 minutes, we multiply 10 times 16, that would be equal to 160. So that 160 represents the square feet that is covered over 10 minutes. Whoops. Let's let that sit for a second. Every minute that is vacuuming or the robot is vacuuming, 16 square feet are being vacuumed. Therefore, if it's vacuuming for 10 minutes, that means 10 times 16, which was 160. That is the total number of square feet that's being vacuumed. Great. Let's take a look at our last example. The last example being, when we look at these tables, can we tell whether or not they are proportional? And we want to be able to explain our reasoning. Well, first thing we're going to do is write y equals kx. Knowing that if we want to figure out what the constant of proportionality is, well, if we just divide by x, so we have y divided by x, and then divide this side by x as well. This is now equal to 1, so k is isolated by itself. So that means k, or the constant of proportionality, is equal to y divided by x. So let's see whether or not these three tables are proportional. First off, when we look at 0, -2, the moment we see that this is not 0, 0, we can say this is not proportional. And what was the reason? What was that word that you needed to type in the chat? Again, origin. Because this doesn't pass through the origin, that's the reason why this is not proportional. Because this is going at 0, -2 instead of 0, 0, that's why we don't even have to look at the other points on this graph. They're not going to be a straight line, therefore it's not going to be proportional. What about our second example here? Our second example, we don't see 0, 0, but that doesn't mean necessarily that this is not proportional. It's just that we don't have that point 0, 0 on the table. However, we can use our equation here to see whether or not they have the same constant proportionality, whether or not there's that multiplicative relationship between the points. And let's see. And if it is present, then that means that this is proportional. So if we look at y, and we're going to divide it by k, so y divided by x, is going to give us k. So 4 divided by 1, 4. 8 divided by 2, 4. That works. 12 divided by 3, 4. Again, that works. 16 divided by 4 gives us 4. Because these are all the same value, it's all constant. There's a constant of proportionality here. This is proportional. And if we were to plot all of these points on a graph, we would see that it creates a straight line, and we would see that this passes through the origin if we extended that line both up and down. So for question number 2 of let's try it, it is proportional because the constant of proportionality is 4 for all the points present. What about the last one, number 3? What's 4 divided by -2? 4 divided by -2 is equal to -2. 2 divided by -1, this is also equal to -2. This is 0, 0, but this is our keyword for today, which is going through the origin. Because it's going through the origin, we know that it's always going to be equal to 0, 0 there, which is great. And what about the last one? 2 divided by 1 is equal to +2. Are these all the same value? What do you notice? Is that constant? Is it the same throughout? And the answer is no. Because this is not constant, there is no constant proportionality here. There's not the same value multiplicative relationship that's occurring with all of them. We can say that this table, these x and y coordinates are not proportional. This input and output is not proportional. Alrighty, kiddos. With that in mind, once again, please put the word origin in the chat. Lets me know that you have watched all the way through. And now let's get to our classwork for today.